Everyone, and welcome to the third lesson in our Getting Started in Stata series. Today I'll be going over how to perform simple linear regressions in Stata. The first step is going to be opening up Stata. Once you've done that, go ahead and import the file that you want to work with today. I'm going to go to File, Import, choose an Excel spreadsheet that I want to work with, and scroll down to my file. So I'm going to be working with some statistics on crime from 1987, and I will import those into Stata. Once you've done that and gotten confirmation you've successfully imported your files, I'm going to use the describe command to figure out what variables I'm working with today. So we have county labels, year, crime rate, probability of arrest, probability of conviction, average sentencing, and some geographic and demographic variables down here. The first thing I want to do is visualize a simple linear relationship with my data. So in order to do that, I'm going to use the graph two-way command, and I'm going to be working with year and crime rate. So graph two-way scatter, and then I'm going to go ahead and build out my linear fit model as well, my line of best fit. So in order to do that, first I'm going to use the lfit command. So I'm going to use lfit for linear fit. I'm going to add ci so I can get a confidence interval in there. And then I'm going to use my y variable first, which in this case would be the crime rate, and then my x variable, which would be year. Then I'm also going to ask Stata to build a scatter plot for me with these two variables. So again, crime rate as my y variable and year as my x variable. Once I've done that, I'm going to hit enter. And Stata is going to build a graph for me. So I probably should have emphasized that because I've used a year and we're only working with values from 1987, I'm only going to have one value of my x variable in this example. So let's pick one that might be a bit more relevant. Let's say I want crime rate and the average sentencing. I want to see if these are related. So, or let's say, let's use a dummy variable first. So I'm going to work with urban. Okay, so when you're working with a dummy variable, we only have values of 0 and 1. It's a binary variable. Really what this is saying is that my average value in non-urban areas is a crime rate of about 0.03. And then my average value in urban areas is closer, a little bit above 0.06. I have a confidence interval showing me the range of values. I'm 95% confident the actual value will fall in. So this kind of visualization begins to make some sense. And let's go ahead and perform a regression, a simple linear regression of the same variables. So I'm going to be working with the regress command. So you put regress, and then your y variable comes first. So in this case, my crime rate, and then I'm going to be using my x variable, which is a dummy variable in this case, urban. So press enter. So we get a simple linear regression here. We have the number of observations, we have an F statistic for the overall significance of the regression, and you can go over to my Principles of Statistics series to learn a bit more about some of these statistics and what they mean. We have an R squared for the regression as a whole, and down here we have my urban dummy variable. We have the coefficient, the beta coefficient representing the relationship of this urban variable and our y variable, the crime rate, a standard error, and then we end up with a very significant result. And Stata also spits out a confidence interval where the range of values, we're 95% confident the actual impact of urban on crime rate will fall within. So let's do this one more time, but with a continuous x variable. So let's do graph two-way. I'm going to do lfit, linear fit, confidence interval for the crime rate and probability of arrest. So I want to know how the crime rate changes when my probability of arrest, for example, increases. Again, make sure you put your y variable first. So once you've done that, you can go ahead and hit enter. Stata builds this graph, and we kind of get an intuitive result. As the probability of arrest increases or approaches 100%, the crime rate tends to decrease. And so we have a line of best fit, and we have a confidence interval for this. Notice that there is an outlier in this data. We have a value for probability of arrest greater than 100. Since we're working in percentage terms, that would be an impossible value. So more appropriately, we would exclude this value from the regression, and we would expect our line of best fit to actually have a slightly steeper slope than it does in reality. So let's now do a regression with those same variables. Use the regress command once more. So regress, my y variable, my dependent variable crime rate, and my x variable probability of arrest. So again, we have a number of observations and an F statistic for overall significance. We have an R² value for this regression, the simple linear regression. And down here, I have my x variable, my independent variable, and I have the coefficient. Again, this was negative, as was visualized with that graph. So the probability of arrest has a negative relationship with the crime rate, which again is intuitive. As the probability of arrest increases, we see a decrease in the crime rate, and this result was statistically significant with over 99% confidence. And once more, that gray band that we saw on the graph is represented here as our confidence interval. This covers simple linear regressions in Stata and how they relate to their visualizations. I hope it was helpful. If you liked this lesson, please like and subscribe. Thanks. Have a great day.